All right, this is the SAAG Security Area Advisory Group meeting. If you intend to be in a different room, please find the room. Otherwise, we are going to get started. We have a really tight agenda today because of the exciting SEC dispatch experiment. So let's see. I think the note well and the other policies that go along with the IPR ones.
Oh, I turned it on because you were. Sorry.
I think it is.
Yeah, yeah, sorry. Yes.
Can you hear me now? All right, great. So welcome to SAG, note the note well, and the IPR and other policies that are within this, and we'll get it up on the screen.
Is it not? Okay.
In just a moment. So I'm Kathleen Moriarty, and this is
Eric Riscola.
all right. Now we are good to go. Thank you. So here's our agenda for today. We're just going to run through our usual administrivia, and then we have one invited talk. So thank you to Min Suk Kang. Well, it's off again. Is that better? No.
I'm going to steal one here while
Is the, okay? So all right, I can hear it echoing. So I'll just be very, very close. All right, so we'll run through our usual administrivia, and then we have one invited talk, and this is by Min Suk Kang on interdomain DDoS mitigations, potentials, challenges, and solutions. So that will be right after the administrivia. And we're going to run through our working groups, and thank you, because I think we have almost all of the reports, so we're just going to breeze through this to try to give more time to SEC dispatch. ACE, we have the report. Acme, thank you for sending it. Curdle, thank you for sending it. DOTS, thank you. I2NSF, thank you. Thank you, IPSecMe. Thank you, Kitten. Thank you, Lamps. This is going to be the fastest time we get through this. Thank you, Mile. Thanks, OAuth. OpenPGP didn't meet. Oh, is it closed? Do we hit the close button? All right, congratulations.
Thank you for your service.
We will update the slides. Yeah, good job. SACM, thanks. SEC events. Is somebody here from SEC event that could get up at the mic? I think that's the only one we don't have. SEC event, going once, going twice. I will make sure it goes out to the list. TLS, thank you for turning that around so quick. Yep. Tokebind, thank you. Trans, thank you. And related working groups. So here we'll just breeze through. We have a bunch of them that got sent to the list already. If you have something important you think should get shared with security area, if you could please, and you represent one of these, please go to the mic and I can say them in case you can't see them. So Anima, and I don't care what order, you'll just have to restate which related working group. Anima, Dbound, Dime, Dispatch, DMARC, Deprive, HTTBiz, Quick, NetConf, NTP, PERC, RADX, CIDR, TCP Inc., and Utah. Any of those? I think some of them we should get some reports that we haven't seen. Going once, going twice. All right, so related. CFRG, we didn't get a report. Does anyone want to give a quick summary? IRTF open. PrivSec, I don't think there's a report to give. We didn't have a meeting this time. And W3C. All right, I guess with that, I think, let's see what the next, BOFs. So we had two, and I believe both reports, oh, I know we have a report for suit already, so thank you for sending that. And the TBOF made their report just in time. Thank you. All right, presentations. Min Suk, if you could please come up, we'll swap over to your slides and look forward to your presentation. Did I set a record?
Yeah, making room. That's annoying. There you go.
All right, there was progress there. Yeah, for a second. I saw
There you
blue.
go. Awesome. Oh, great. Okay, you're good.
Okay. Hello, can you hear me back there?
You gotta get
No.
closer.
Closer, even closer? Oh,
Yes.
maybe.
Yeah, you can pull
Oh.
off if you want.
Okay, pink box. Thanks. Okay, good afternoon, everyone. My name is Min-Soo Kang. I'm from National University of Singapore, local. And I'm also a first attendee of the IETF. I'm enjoying this first time event for me. And today I'm going to talk about our ongoing project, very recent ongoing project on the interdomain DDoS mitigations. And I'm really happy to discuss this with you guys, with IETF community, because I believe that this topic is especially related to some of the working groups, including DOTS and the TEEP. Oh, is it working?
Yep.
Okay, cool. And as I said, this is an ongoing work. So if you have any suggestion, feedback, and anything after the talk, just please let me know. That would be really helpful. And have a clicker. So as many of you already know, large-scale volumetric attacks are so common these days, and they often congest more than one networks on the internet. And we've seen the escalation.
Closer.
I think it's on and off. Do you hear me? No.
That's not him. That's
I need to wake it up
Few of the rooms.
frequently.
all.
All right, thanks.
Okay.
Hello? Cool, thanks. So we've seen the escalation in volume of DDoS attack traffic. We've seen 300 gig in 2013 and 1.2 tera last year. So huge increase. And the volumetric attacks often flood upstream autonomous systems as well, according to a recent Arbo Network report. And worse yet, there has been a couple of advanced link flooding attacks from academia, including core melt and crossfire attack. That claims to be able to, launch flooding attacks against the links that connecting multiple ASs or even the, links inside an AS. So this interdomain DDoS mitigation sometimes becomes really necessary for against the large-scale volumetric attacks. And in particular, interdomain packet filtering operation is often necessary when inter-AS links are flooded, and then they, each AS cannot do anything about it, and large portion of AS is just flooded, and they have no capability to, filter those traffic, so they need to ask their upstreams. And typical form of this interdomain packet filtering is this outsourcing mechanism. That is, an AS asks another AS for packet filtering. And the state of the art of this kind of outsourcing has been noticed recently by AT&T and CenturyLink. So they announced in the last NANOG meeting last month, they announced that they've been working on the automated packet filtering outsourcing between the two ASs for DDoS mitigations. And of course, IETF thoughts has been really doing a great job in standardizing common channels for interdomain coordinations. So when you talk about the interdomain mitigation for DDoS, actually the holy grail of the interdomain mitigation is what we call the source end filtering, where destination AS directly talks to the AS that are actually serving those potential attack sources by directly saying that, hey, please drop XYZ packets. And then, source AS, okay, I will set up, some firewall or packet filters, and then the packet are dropped at the source AS, and the DDoS attack at the destination is mitigated. And this is actually an ideal form of DDoS mitigation because it really stops the attacks earlier by outsourcing the filtering to the source AS. And a couple of examples including DWORD or StopIt, in terms of academic projects. There has been clear advantages: reduction of bandwidth waste because you stop the attack, at the source, not at the destination. So you can save lots of bandwidth and you can reduce the cost. And also some resource demanding filtering operations like complicated rate limiting can be executed at the source AES, because source AES is not under attack, but destination is under attack. So they have resource. Also, some local context at the source AES can be utilized. For example, the source AES may know some, user suspects, list of user suspects under their customer networks. So it can be actually used. So this source end filtering looks really fine, but this has not been deployed in the current internet due to the lack of trust between AESs. So what I mean by this is simple. Source AES and destination AES, they actually mutually untrusted. The reason is that there's no direct business relationship between the source AES and the destination AESs. They are multiple AES hops away from each other. They are basically random guys on the internet, and there's no direct agreement between the two, so they mutually distrust each other. And these mutually untrusted AESs may launch attacks to each other. For example, the source AES on the left-hand side may try to modify the requested policy from the destination AES, the request. And even worse, it may leak the requested policy from the destination AES. Also, the source AES may not have any strong incentive for doing this for the source AES. Because filtering operation at the source AES incurs non-negligible cost. So really, the source AES needs a strong incentive to do that, but we don't see the strong incentive for this. And worse yet, there is a risk of dropping packets for the source on behalf of others. So at the end of the day, the source is helping the destination AES, which is random guys on the internet, and the source AES may be blamed for dropping its own customer's packet at the end of the day. So to that end, we believe that in order to actually implement this source end filtering, we really need to think about the collaboration rather than the outsourcing. So what that means is that source and the destination AESs collaboratively determine the filtering policies. So as you can see in this animation, destination AES submits its own policy, filtering policy, to the source AES, and at the same time, source AES submits its own policy, its own filtering policy, to this the packet filtering mechanism, and those two policies are composed into the composed policy PSD here, and this composed policy is used to filter traffic for the DDoS attack at the destination AES, and we believe that this collaboration, pure collaboration architecture provides significant incentive to the source AES, because source AES now can express its own policy and for its own customers. For example, let's say the source AES has some premium customer or mission critical service that he really wants to protect when there is an attack, attacks at the destination AES. And now the source has an opportunity, has a capability to express that and really enforce that. But as we try to really implement this, pure collaboration operation, we immediately faces a couple of security challenges. First, how can we really guarantee the fair policy composition between the two, source AES and the destination AES? And at the end of the day, they are untrusted. They don't trust each other. How can we do it in a fair manner? Second, how can we protect the sensitive filtering policies from each other? Those two untrusted AESs submit their own policies, independently created policies, and it is combined in some way. And how do we guarantee the privacy of those policies? And the third, what if the source AES, who's actually executing the filtering operation, wants to bypass the packet filtering when it doesn't like the decision of the packet filtering? So these three, security concerns are really the major concerns we discovered, and we just summarized a couple of desired properties for this. So first property we really need to have here is what we call the verifiable fairness. So that is, policy composition of the two must be fair and verified by both source and destination AESs. So again, this is a collaboration platform, not the outsourcing platform. So the fairness really is the key between the two untrusted AESs. And by fair, what we mean by is that we try to find the middle ground between the two policies, two independent policies. So in this very simple example, on the left-hand side, there's a source AES. Source AES may have four policies. Four flows, and the top one is has a higher priority, and the bottom one has a low priority. Flow 1, A, B, C, D, and destination AES may have different policy in different order. For simplification, we assume that they have same flow definitions. But as we compose those two different policies, we may come up with a composed policy that is roughly in the middle ground between the two. So that's roughly the idea. Of course, we have better definitions in our working papers. So maybe the more important part is that the two AESs should be able to verify that the fair composition and enforcement of their policies are there, and should be really verifiable by the two untrusted AESs. So that's property number one. And the second desired property is that filtering policy of each AES must be protected from each other with some privacy guarantees. The reason is really simple. Filtering policies are inherently sensitive. For example, the preferences of the filtering rules could be from private contracts between AESs or proprietary algorithms. Or the policy rules may leak some of the attack information. For example, which customer is actually under attack, or it may leak some vulnerable points of their networks. Also, it may leak some internal whitelist and blacklist policies of their, which they never want to reveal to any other AESs in the world. So what we want to have is just to have some negotiation mechanism that guarantees some level of degree of privacy. Lastly, third desired property is simply just to make this bypass attack impossible. So in other words, source AES may want to evade this filtering policy, but we need to have this, what we call the non-bypassability property, so that any filtering operation must be invoked for all packets from source AES to the destination AES. So to that end, we actually design and build this Middlebox-based filtering mechanism. And we believe that this is a really practical design choice for rapid and widespread deployment. So in this simple diagram, on the left-hand side, there's a source AES. On the right-hand side, destination AES. Again, they are far away from each other. They don't trust each other, of course. And our idea is that we put the Middlebox inside the source AES, and this can be right next to the egress router. And simply it receives two independent policies from the two networks, source and destinations, and the policies could be 5-tuple flow definitions and with some priorities. It could be some other things, but just as an example, that could be a policy, and it is composed into the common policy, and which can be fit into the classification and the rate limiters. So there could be multiple rate limiters for each traffic classes. And so when this Middlebox receives the incoming packets from the source and to the destination, again, the destination is under attack, and destination is requesting some packet filtering. And based on this composed policy, they drop some of the packets. In other words, rate limits some of the packets, and then the remaining packets will go to the destinations. So it actually, we built everything with commodity hardware, and we could achieve multi-gigabit per second throughput. And the two major functions, the control plane functions and data plane functions are protected within the trusted execution environment. So trusted execution environment, or TEE, is used because these capabilities, the memory isolation or isolated execution and remote attestation, would be really, really useful to offer security properties for that. And one of the biggest one is a verifiable control and data plane operations. So we show that this TEE-based Middlebox for the application of collaborative filtering can actually satisfy the three desired security properties. If you remember those three, I'll remind you. The first one is that policy composition and enforcement of the two policies can be actually isolated and verifiable by the two AESs, because every the executions of the policy composition and enforcement are protected by trusted execution environment. And also, this AESs now can negotiate the desired level of privacy. So, for example, if the source AES is trying to learn the composed policy PSD here, then he can actually try to do that. We actually demonstrated that the attack is possible within less than 10 seconds. But we also found that there is a trade-off between the anonymity and the fairness, privacy and fairness. And by writing down exactly what level of privacy is required by the two untrusted AESs, we can actually provide the desired level of privacy. Also, bypass can be immediately detected and with a secure per packing logging at the Middlebox. Also, this per packet logging should be implemented within the TEE, because we need to provide authenticated the logging information. There's a little bit of performance issue here, because in order to do that, we may need to copy all the packets. I mean, the line rate to the trusted execution environment. So in order to solve that problem, we propose a near zero copy technique that copies only the 5-tuple information into the TEE, which enables us to achieve multi-gigabit per second performance. So we actually designed and implemented this Middlebox using Intel SGX in the Intel SGX platform. So and we could achieve so far 1.8 gigabit per second filtering performance throughput with 3 Intel SGX cores. So we actually have 4 cores, so there's room for improvement. We're actually optimizing it, and we used Intel CPU memory and a network interface card. They are all commodity devices, and TCB is about 1.3K source line of code, and we integrated the SGX with the DPDK for higher packet processing, and imported a couple of libraries to the SGX. So our plan is to scale out this thing with securely load balancing and the parallel Middleboxes for up to 10 gig or even higher throughput. So in conclusion, I try to talk about this interdomain DDoS mitigation, and in particular, I try to convince that collaborative source end filtering is really the one that we need to design, and it is possible. So so the potential is really clear. This is really the ideal form of defense for large-scale DDoS attacks, but there's a challenge. AESs do not trust each other. And the solution is that we need to really, move from outsourcing to pure collaboration. And in order to achieve this collaboration, we need, as one solution in point, we propose a TEE-based Middlebox, which satisfies the 3 security properties, that is verifiable fairness and the privacy and non-bypassability. So thank you for listening. And again, this is a really ongoing project. We are probably on the halfway through writing a paper and optimizing our implementation. So if you have any suggestion, any issues with assumptions or anything, we are really open for feedback, even collaboration, if you can contribute to this. Okay, thank you.
Hi, Roman Danilo. I'm co-chair of the DOTS working group. We've talked. Thank you for the presentation. We as the working group are not doing anything near as sophisticated as that. We're of course doing kind of hop by hop signaling, and I just welcome you the same way you were talking about collaboration to come work with us, and if you have ideas and suggestions on our work as well. Thank you.
Okay, thanks.
Hi, Kyle LaRose, Sandvine. Just a question and a comment. So question, you said 1.8 gigabits a second, but with packet processing applications like this, often the packet rate is more important. What was the packet rate? How small were the packets that were being filtered?
So I hear packet rates and the smaller packets. Can you? It's really.
Sorry, I was just wondering what the packet rate you were filtering was, because usually that's more important, particularly at low bandwidth like that.
Oh, other than the bandwidth, packet rate is more important. That information I need to check with my student. But I'll.
You just want to consider that, because 1.8 gigabits a second of 1500 byte packets isn't really that impressive. But if it's 64 byte packets, that's actually quite a lot.
Yeah, I agree with that. You know, the throughput in terms of throughput is not that impressive. The reason we have this degraded throughput, not the 10G, is that we're using SGX, and it naturally incurs context switching. We're trying to minimize the context switch, and that's the result for now. And
then I guess one comment related to the zero copy. I mean, you don't incur the copy cost, or all the mem copies and stuff, but you still have to send that packet somewhere. So there's going to be implications to the PCI bandwidth of your system, any other interfaces that you need to send it out of. So I'm not sure that logging every single packet that gets through the filter is necessarily a good idea, because that itself is an attack vector on your Middlebox. So it could be brought to a halt or stall out or something if you're not careful about allocating resources to this copy.
So I understand that you're concerned about this per packet logging and zero copy stuff. So yes, exactly. That's really the biggest part of our performance issue. And then we try to minimize that using near zero copy, meaning that we try not to copy anything but 5-tuple information. And we believe that 5-tuple information is actually necessary. We need to copy that into SGX in this case, because we need to really detect the bypass attack, and that's the only way, as far as I know. For now.
All right, thanks.
Okay, thanks.
Hi, Daniel Kahn-Gilmore. Thank you for the presentation. I'm trying to understand, get my head around a couple pieces that seem to be missing to me. So one thing is that the bypassability that you describe, if the only input to the trusted execution environment is the 5-tuple, and then the only output is an approve or disapprove of the 5-tuple, then how does that produce non-bypassability, right? So I learned from my TEE that I'm supposed to drop this on the floor, but I don't. Right? So how is it not bypassable? It seems eminently bypassable to me, because the actual sending of the packet is not, of course, within the TEE. My second question has to do, or I don't know if you want to give feedback for that, or my second question has to do with, you've presented this in a two-party scenario. You have one source AS and one destination AS, and I'm wondering what the state of the work is for dealing with the fact that actually there are thousands of ASs on the network. How does it scale to the end party scenario?
Okay, so let me answer to the first question first. So the question is that 5-tuple is good enough for bypass detection. So if you really want to detect per packet bypass, if you want to detect if there's any packet that's trying to bypass it, then it's insufficient. But our goal here is to detect the bypass between different cross the traffic definitions or traffic classes. So in other words, maybe I missed that, skipped that part, but our Middlebox is securely logging all the packet counts per traffic class, and the destination should be counting the same thing per packet, per traffic class, and they compare it at the infrequently. So if some packets are missing or some packets are injected within the packet class, traffic class, then that can be detected. But so in order to achieve that property, that level, that granularity of detection, 5-tuple seems to be a reasonable compromise.
So what is the recourse for the destination AS if the source AS is allowing bypass? You're saying now it's not non-bypassability. Now it's detection of bypass.
It's a detection. Yes, it's a weak form of non-bypassability.
So if I'm the destination AS and the source allows a bypass, what is my recourse?
So allow, you mean the.
So you detect a bypass, right? You're the destination AS. You detect a bypass. what's your recourse? What do you do?
So what do you do? So if you detect it, then since this is a bilateral relationship, only between the source and destination. So if destination clearly knows that source is trying to bypass it, then their temporal contract is over. This collaboration is just aborted. So that's we believe, detection might be sufficient because it's just between the two AESs.
Okay.
Yeah, it's something we had to make. This design point is because of this performance issue.
So how do I know? Can you go on to my second question, which was about the end party scenario? How do I as one AS negotiate these contracts with the thousands of other ASs that are out there?
So we know that the malwares are distributed across the internet, but their distribution is not that uniform. So we are assuming that the source can identify a reasonable number of ASs that's producing large number of packets. The contract should be bilateral and independent. So destination should be able to make individual temporal contract with the multiple source AESs. That's what we assume. Okay.
We're going to cut off the mic line in the interest of time.
Okay, this is Linda Dunbar. I'm the chair of the working group Interface to Network Security function, which is to standardize the policy, like a filtering policy. And in our working group, we have a domain like a controller and then the function. So there's a relationship. But for your case, I'm just curious, do you have a controller to send the policy, or you're depending on just between AS to send the policies?
So I'm not sure if I really understand the policy part.
Our working group is to define a standardized data model between two peers, like between you and me. I want you to filter certain packets, so we standardize those kind of policies. So my question to you is, as earlier person was asking, do you have kind of a hierarchical way, like have a controller to tell all the ASs of the policies, or is it purely distributed?
So for now, this is a purely distributed P2P model, but later we will consider more hierarchical way where there's a central, controller globally, and then assign these things in a more organized way. But for now, this is a purely P2P.
Okay, so are you assuming in each AS there's a Middlebox there to be able to do all the filtering?
Yes, in order to really enjoy this capability, yes, AESs should have a Middlebox.
Okay, that seems very expensive solution. That's my comment.
Ben Kaduk. So I guess I want to try harder to understand the trust part of this. So we start out with the two ASs that don't trust each other.
Yes.
And I guess the source AS has the Middlebox. And so then they come to talk to each other. And I guess, is the trust rooted in the manufacturer of the processor that has the trusted execution environment?
Yes. So that's right. The root of trust about the operation, the execution of this fairness and the enforcement of the fair policy comes from the manufacturer. In this case, Intel. In the case of Intel SGX, it's yeah. If you use TE, that's something you need to assume. Yes.
Pernille Sunet. I'm sorry to say I can't see this working ever. BGP is not technology. BGP is politics, right? So people setting their policies, people are making money on DDoS attacks too. So I don't see anyone using a box like this because you won't put your trust in someone else. And again, but verifying who are using it and who are not using it. You said you were half through. I think you should go back and look at from the start again, because this will never ever work.
And
this has I would say content data networking has a bigger chance of working than us.
I'm sorry, I missed the last part. I guess
that was just a comment.
Okay, so
So I'm saying
So
you
if you-
should
if
go
you can
back
be
to the drawing board
constructive, too.
and look at it again, because this will never work. No one will use this.
If you could be constructive too, that would be good,
I
just to
don't
help
know
with the
how to
tone
be
of the meeting.
How can I be constructive? Because the BGP that's not how ISP. I run an ISP. We will never use it, and I promise you, my friends in other ISPs will never use a box like this. And that's because we want to set our own policy. That's what you do with BGP.
yes, this is actually sort of doing that. It allows you to express your own policy for
No,
filtering
someone
the
set the
traffic.
policy for me, because someone is setting me to do filtering going out, right? And
So that's an outsourcing model. A is setting a filtering.
no, but I
to-
still saw that I get some policy towards me, right? And
Yes,
the question
yes.
is, so should I sit and monitor all these policies coming in if we have 65,000 AS numbers out there that are sending me policies all the time? If everyone is using this does not scale.
So
Sorry.
maybe I can clarify this. This is used only when there is a DDoS attack. In the normal peaceful situation,
There's
we're
always
not going to use it.
they're continuing DDoS attacks all the time.
I think he understands your point.
Yeah. So when DDoS attack really happens, what the current the situation is that maybe you know much better than I do, but when the filtering is happening at the destination AES, then source AES has no control over whatsoever. The destination will determine which packet should be dropped or not. And now it enables the source AES to express certain level of policy. And at the same time, the destination AES will benefit from this mechanism because it can sort of outsource the packet processing to the source AES. So I mean, my argument is this is a win-win situation.
No. Again, I told you that our ISP is making money on DDoS too, right? So people want this DDoS.
Okay, I think we're going to move on to the open mic.
Yeah. Thanks for that comment. Yes.
All right, thank you very much, Minsuk, for your research and presenting it here today.
Yeah.
And
Thank you.
If there's additional constructive feedback, he is very open to receiving it. So thank you. And open mic?
Hi, Governor. Since I didn't make it to the sector dispatch, to sec dispatch, tonight at 6 p.m. we're having a small meeting about short-term certificates, about the considerations for using them, and whoever wants to participate, you're welcome. We'll be at the Hollet Room.
Thanks, Yoav.
Hi, I'm Jim Fenton. I've been reviewing a few internet drafts lately that have the security considerations aren't quite what I would like them to be. In particular, people seem to be putting a lot of normative content there, and I'm concerned that having it there in security considerations, which I consider to be more of a discussion of the characteristics of what was said earlier, is kind of the wrong place, and implementers are likely to miss content that's there. So what I'm wondering, and RFC 3552 doesn't say anything about not doing that. So I'm wondering, is there any plan to update that? And if so, can we add this?
Funny you should ask. We've tried. So there's a few things to respond to there. There is no strict guidance on how we structure the security consideration sections. There have been experiments where people have done a security requirements section and a security consideration section. I haven't seen one of those in a while. And that's a case where you would separate out any musts you didn't have before and put them in. So no, we don't have any strict guidance on that. If you do see problems and you could clarify documents, of course, responding to the editors and working group is much appreciated. So your reviews are much appreciated. To get to a revision of 3552, we need feedback, right? So Yoav had graciously volunteered. He had brought up, he had done a presentation with a prior volunteer. I think I want to say it was like Berlin. That might have been one of the meetings, but he got up here and we gave overviews at several meetings, several SAG meetings. He requested feedback at the mic. We had discussions on it, even just 2 meetings ago, asking for feedback. We had lots of enthusiasm in the room and said, all right, we're going to do this. And nothing came in. So if you'd like to give feedback on that and see if you can drum up support for that, we'll see if Yoav is still interested and has the time for that, or find other editors. But it's been a lack of community interest in providing feedback.
Okay, I'll look for I wasn't aware of those other presentations. I'll look those up and maybe get in touch with them. Thank you.
Thank you. And you could just post, if anyone's interested, post to the SAG list. We'll see if there is enough interest. And if there is, we'll go forward with it. It would be a good thing to do. Anything else? Okay, so now we will switch over to Sec Dispatch. And if you have feedback from the Sec Dispatch experiment, please send that to Ecker, I, and the chairs, Tim and Nancy.
Start out with what the explanation of the 2 cards. Okay. So just, oh, you do. Okay. Go for it. More organized.
Yeah. Well, we are really organized, trust me. So welcome to the experimental security dispatch. So we are trying this for the first time, so bear with us. Real quick, I'm not going to go through the note well. Hopefully you've been through enough sessions, you know what it means. What I want to say first, and why I'm circulating 2 cards, is originally we had slated Russ Housley to be my co-chair. Unfortunately, he was taken ill. The good news is he is out of surgery. So we want to wish him well. We're circulating 2 get well cards, so please feel free to sign them, but please make sure I get them back at the end of the session. So very important, so he gets it. And I do want to thank Tim for stepping in at the 12th hour, really. So with that, given the experimental nature of this, what we're doing is we're mimicking the process that is being done by the ART dispatch. So that said, we're here really to help, as the group is namely apt, to dispatch the work. So given the full agenda, and typically in the ART dispatch, the presentations are given about 10 minutes, really more like 5 to 7 minutes for them to present. We discuss, and then we ask the question to you whether it is something that the IETF should do. If it is, we get to discuss whether there's a home within the IETF. And if there is, great, we'll make sure that those chairs are aware. If not, then we ask the further question as to whether we should form a new working group, or whether we should ask one of our security area directors to sponsor. So hopefully there are no questions, but maybe we'll say 1 minute if there's any questions, clarifications. Quickly, going once, going twice, good. We've got a full agenda. So with that, we've got 5 presentations, and if time allows, there's potential for a 6th one. So with that, we have Ron. Are you on Meet Echo? Push the button. Push the button next.
Hi, everyone. Hi, Tim. Hi, Nancy.
Hi, Ron.
Are you able to hear me?
Hi. Good evening. So give me 1 second here. I'm going to put your slides up. I'm trying to make it go full view, enter full screen. All right. So go ahead.
Hi, everyone. Well, first of all, I'd like to wish Russ speedy recovery because he's the one who first contacted me about this. And thank you to the SAG chairs, and thank you for Nancy and Tim for hosting this session. Today I'm here, I know I only have 5, maybe or 7 minutes, but I'll go through it really fast. So today, this presentation is about an open PGP extension for the OSCCA algorithms. So if we can go to the next page, I'll explain to you what OSCCA is. So in China today, there is an institution called the Office of State Commercial Cipher Administration, which in short, we just call it OSCA. It governs usage of cryptography in China, and especially it is enforced in hardware designs where non-approved cryptographic algorithms are disallowed. So we're talking about the normal ones that we see, the SHA, AES, and those ones. There are actually only 3 OSCA-approved algorithms, and these are named SM2, SM3, and SM4. So the names SM actually refer to an acronym in Chinese, which means commercial cryptography. SM2, so I'll explain these 3 algorithms in the coming slides. Our extension extends OpenPGP to allow these 3 algorithms to exist in the protocol, so people in China could use encrypted email through OpenPGP. So this draft defines the usage of these 3 algorithms within OpenPGP and also an additional profile, just like the NSA's B suite, we call it the OSCA SM234, as a profile for OpenPGP usage. Can we switch to the next slide, please? The first algorithm I'd like to explain is the SM2. It's an elliptic curve crypto system defined in the standards that were just published and actually just went active earlier this year in March. This is the family of standard called the GBT 32918 from part 1 to part 5. Different parts of this standard define different parts of this algorithm. So this is an ECC that contains 3 separate algorithms. It's a digital signature algorithm, a key exchange protocol, and also a public key encryption algorithm. The last part, part 5, defines the SM2 curve that is recommended. So the SM2 algorithm uses a 512-bit public key, a 256-bit private key. For more details of the algorithm, you could have a look at this draft, draft Shen SM2, blah. A short history of this algorithm, it was first published in 2010. It was standardized as a commercial cipher in China in 2012. It was included in an ISO standard in 2015, formally standardized as a national standard in 2016, and this year, actually last month, it was included in the latest ISO digital signature standard, 14888. Specifically in OpenPGP, we utilize part 2 and part 4 of the standards for digital signature and public key encryption. The usage of SM2 adheres to the data formats specified in GMT 0009-2012 for interoperability. It defines an ASN1 format that is already implemented in cryptographic libraries like OpenSSL and Botan. The users of OpenPGP with SM2 uses the part 5 elliptic curve defined, which is called SM2 recommended. The next slide will tell you about the SM3 hash algorithm, which is defined in the standard mentioned above. It is a 256-bit digest algorithm designed as a replacement for SHA-256. It was designed by Professor Xiaoyun Wang, who was you probably remember was quite famous for the SHA-1. Its a brief history is that it was first published again in 2010, standardized in 2012, published as a national standard in 2016, and this year again, just a couple months ago, it's now included as an international standard. In OpenPGP, we use it as one of the registered hash algorithms. So SM3 could be used together with other public key algorithms, such as RSA, SM2, and so forth. The next slide will give you SM4, which is a 128-bit block cipher. It uses an 8-bit Xbox with 32 rounds of processing. For more information, you can look at this draft at the second point. The SM4 algorithm goes back to 2003, where it was standardized in this GB standard for wireless LAN. It was designed for wireless LAN encryption, and therefore it's a short block cipher that has supposed to have excellent reliability in simple hardware. So it was published in 2006 as by the OSCA, standardized in 2012, published in 2016 as a national standard, and 2017. A couple months ago, it was added into ISO 18033, which is a document for block ciphers. In OpenPGP, we use it as a selectable symmetric encryption algorithm as an alternative to AES 128. And the last slide I would like to show you is that SM2, SM3, SM4, the implementations are already provided in Bolton, in OpenSSL. Support in Embed TLS and LibreSSL is coming. A number of processors today already implement SM3 and SM4, including Intel chipsets and upcoming the ARM V8 cores. We have our own implementation of OpenPGP called RNP. We already support all of these algorithms. And in terms of security considerations, there are no feasible attacks against SM2, SM3, and SM4 today. For more details, you could have a look at the IETF drafts. So proposing to move forward, this document, given that the OpenPGP workgroup has recently encountered some turmoil, we would need a security area director for sponsorship. We would like to request 3 extra code points in the IANA PGP registry, which is listed here. For the document, we would like to add more examples, and we would be very happy if anybody could provide some constructive feedback and reviews of the documents. Thank you very much.
Thank you, Ron. Just to add a little bit to that, so to actually use those algorithms with OpenPGP will require those code points being assigned. Those code points have to be assigned under IETF review.
Yes.
Ron already did some of the ran the algorithm. OpenPGP would have been the obvious home for this work. It's closed. I don't see a new working group opening. So the question is really whether this work is important enough to move forward under AD review. So we have a line at the mic. If you could, folks could be quick. Thank you.
Hi, this is Daniel Kahn-Gilmore, ex-chair of the OpenPGP working group. Thank you for bringing this up. I'm sort of curious about why you're proposing it now when it looks like these things have been around for several years. I was looking at the drafts. There's a sort of strange chain of when the drafts were formed. This would have been a good thing to mention probably in the OpenPGP working group when it was open. So I'm sort of curious about why do we need to do this at this point instead of when there was a working group?
Yes, so I was actually previously in contact with Barry, and he suggested to me that the OpenPGP working group was only going to deal with the revision of 4880, and that
which involved a cryptographic refresh, right? Like that was the attempted goal.
Yes,
was a cryptographic refresh.
Yes.
So here you're offering updated cryptographic algorithms.
Actually, I was specifically referring to this draft when I talked to Barry, and Barry suggested that I contact the security area directors directly rather than going to the group, because the group, the charter of it was specifically just to revise 4880 for, whatever problems people had with it. So he suggested that we bring this directly to the area directors to not disturb the work of the group.
Okay. Yeah. The work was disturbed as it was. I see.
I'm
I'm
sorry about
the
that.
line there, and people need to be brief.
Hi, Sean Turner. I'm probably not going to be nearly as entertaining as DKG.
Hi, Sean.
Why we're here, though, right, is because the IANA registries are set up as IETF review.
Yes.
So you can't get a code point unless you get AD sponsorship.
Yes.
So another solution to this is to update the registries to allow other specification types. Then you can get a registration and go either through an area director or to the ISE. It's your call. But that's it has nothing to do with your draft.
Right.
That's just like procedural mechanics that would have to happen.
Thank you, Sean. I totally agree with that. It's just that, that's how it is right now. And I think we need to update, some RFC in order to make that possible.
Right. Okay. All right. Well, it's another option.
Thank you, Sean.
Thanks.
Stephen Farrell, just a comment,
Hi,
maybe not constructive, sorry. So I think having specifically supporting Suite B was a mistake. I think adding other national algorithms would be a mistake. I don't think we should do any of that. If we want new algorithms, it should be because they're better, not because they're, belong to some geography.
Thank you.
So this is Richard Barnes. So I just wanted to confirm that this looks like it has kind of the same API footprint as the algorithms OpenPGP is already using. So this really is just a code point assignment. There's no new mechanism or protocol around this.
Yes, you are right.
Yeah. So I'm just going to +1 Sean here, saying that we should probably just fix the registry here. I think this would also, if this hasn't been kind of through the CFRG process, I think it would be beneficial to kind of get some of those folks to take a look and give it a thumbs up or thumbs down.
Sure. Thank you.
Hi, Sean Leonard, Penango Inc.
Hi, Sean.
Just for my edification, as well as others in the group, what is the status of implementation as well as specification in the ASN1, SMIME, CMS certificate realm? Because unlike the registry issue that we have with OpenPGP, where it requires IETF review, you or whoever can just assign an OID and by agreement start using it, right? So, but could you address that a little bit?
Right. So OpenPGP unfortunately, it doesn't directly utilize OIDs in the selection of algorithms. It was like that for, I guess, a long time. So it boils down back to, the code point registry issue, that, for OpenPGP to work with these algorithms, it is necessary to update that without actually changing the protocol. For the SM algorithms, SM2 specifically is actually already used in the certificate standards. However, those are standards within China. So those are only national standards that apply SM2 and the usage of SM3 as a hash algorithm within, for example, SSL certificates. So that is already in use today. However, there is no specification at the IETF on how this is actually done in English.
Got it. And is it your view or your opinion that perhaps it should be documented in the IETF because there is deployment, even though it's in one region?
Well, I would say, it would definitely be beneficial if there's actually an official specification that is at the IETF. I think that would be very helpful, at least, for the IETF community. So I would like to answer one more question about, why this is why do we propose this now? Is that because SM2, SM3, and SM4 has just been standardized. They actually just became active earlier this year. And in fact, the SM2 curve is not yet active. It will be active in early 2008. So this is when everything comes together that is actually usable.
Makes sense. Okay.
Thank you, Sean.
I mean, from my perspective, I think that My personal view is I don't see it as harmful to have more definitions of cryptographic algorithms and using them because I believe in cryptographic diversity, in contrast to some of my colleagues, whatever. Basically, I don't believe in the Sith rule of two when it comes to algorithms. I think defining more is better. Choosing whether to use them is a very important issue, but that's sort of orthogonal to getting
Right,
the assignment.
that would be a different consideration, I believe.
Yeah, I think it's okay from that perspective.
I fully agree with you. Thank you, Sean.
This is DKG again. I'm speaking here from someone who's been in touch with several implementers in the OpenPGP space. Do you have? I see you have a list of implementations in Botan and OpenSSL and Embed TLS, none of which I believe are OpenPGP implementations.
Yes. So SM234 are cryptographic algorithms. So what that point meant was just that these algorithms are already available if any implementer wanted to use them. So in terms of implementation of this, our own implementation called RNP, which you could find on GitHub, it's an open source project. It already supports the usage of SM2, SM3, and SM4 in OpenPGP. So right now we utilize experimental code points, but if we get a registry to insert our code points, then it would be already a standardized implementation.
Okay, so despite what Sean said earlier, I believe that for the elliptic curves in particular, we do actually have OIDs. We do use OIDs within OpenPGP to identify the curves, right?
That's true.
So that should not be a requirement. Like you don't need to do anything there. You just can stuff the OID in for doing your ECDSA. Yeah.
Yes, that's true for ECDSA.
Okay.
For example, if you want to use SM4 for symmetric encryption, we would need it would not be the OID.
Okay, but your bulleted list here includes the public key algorithms, which I'm assuming is ECDSA, right? Or the equivalent of the ECDSA. So you're asking for an additional code point beyond?
Yes, that would be to use it as a public key algorithm, just like how RSA is used.
So I'm not convinced that that's going to be necessary, but I have to look at the crypto for it. Sorry.
Sure.
Okay, so based on the comments and discussion, it feels like there's a couple of paths. As Sean suggested, and I can't remember. Oh, there's three. Okay. Yeah. So the first one is we don't need to do anything here, or we don't want to do anything here. The second one is, as proposed here, we find an AD to sponsor. I don't know where Eric went. Well, Kathleen's on her way out, so. And the third option is, as suggested by Sean, we really don't need to go through the draft. Rather, we need to go through the IANA registry. And even in the registry, I would put the question as to, for SM3 and SM4, we need the IANA registry, not clear that we need to do it for SM2. So given those three options, I'd like to do a hum.
Implicit in the CFRG review.
Oh, yes. So you should have done this. So implicit in the AD review, see, you should have done this.
Implicit in having it go to an AD would be a CFRG review first.
Hi, Eric Wishkola, AD.
Hi, Eric.
Kathleen can speak for herself, but I'm not going to AD sponsor a document that adds a code point for this. I'm not going to AD sponsor a document that adds a code point for this because I think that having AD, the precise purpose of having sec dispatch was not to have a bunch of algorithms that had to go to RFC so we could AD sponsor them so they could have code point assignments. So I'm happy to have, I would AD sponsor the thing Sean suggested, which is loosening the registry, and then they can do whatever they want. Kathleen must AD sponsor, that's her choice, but I'm not going to AD sponsor like a draft that's basically a document that exists only for a code point assignment. I don't think that's useful.
So if there's no AD that would be willing to AD sponsor that isn't a choice. Although that's not quite what we thought we'd signed up for here, but that's I understand. So we'll do
Kathleen may feel differently. I'm not trying to say what you should do.
Of do people think that we should pursue, that doesn't mean we'll actually do it, but we would pursue a change to the IANA review policy for OpenPGP so that future algorithms can be done without being something that has to be done through the group. And I think we should do a hum on that. We are out of time. So let's start with that. How many people think that that is, I'm sorry. So,
but I have one comment actually. There's a kernel working group that is working on adding things and so on, and it doesn't list the PGP, OpenPGP, because OpenPGP working group was alive at that point, but it's not anymore. So actually, we could add this to kernel charter. That's something that ADs could and the chairs of the kernel working group could think.
Kernel. Definitely was. So you're saying it could go to kernel as the working group. You thought it could go to. I wouldn't have thought. I didn't think that when I reviewed it, but that's
okay. It could go to kernel, I think, but the thing is, it doesn't solve the long-term problem.
Okay.
Which is
So
raised by.
we're gonna do.
Sorry, now I really take this before you cut me off again, and I move. I definitely am in strong support that we solve this question as Sean proposed, and I ask the chairs whether we can hum on that.
So we're going to do three options. The number one option is that we would do nothing. The documents is something we don't want to pursue. The number two option, these are not in order, these are just the three. The second one would be we revise the IANA policy for OpenPGP. And the third is that we ask Ron to take this to Kernel and see whether Kernel is willing to take it on as a working group item.
Before that, I'm channeling PHB. No, the algorithms Kernel can add are fixed.
What?
No, the algorithms that Kernel is allowed to add are fixed.
Right. No, that's true. It would require Kernel would have to decide that they were willing to change their charter and request a charter change to be able to pursue it. So, number one. Okay, we're clearly not going to.
This is DKG. I just want to clarify for folks, since we're talking about humming on changing the IANA registry.
Right.
Not everyone maybe knows what the IANA registries are here, so I just want to provide a point of information so people can know what they're voting on, or humming on, or whatever it is that we're doing here. So, the registries I believe that we're talking about are 1-octet registries, right? And we're talking about changing the IANA registration policy for a 1-octet registry that currently is set up with, depending on which one, there's between 10 and 20, 10 and 24 points assigned out of the 256, with a range of 10 reserved for private experimental and nothing explicitly assigned above 128. So we're talking about changing IANA registration policies for relatively small registries.
Thank you, DK.
That is a really great clarification. Thank you for pointing that out. With that, we're going to still back to the three hums, which is don't think the IETF should pursue this. Number two would be change the IANA policy in spite of it being a scarce resource. And the third one is ask Ron to first confer with CFRG and then take it to Kernel. So that's a two-step process on the third one. So on the first one, how many people think that this should not be pursued? Hum now. Okay. How many people think that the IANA policy should be revised so that IETF review is no longer required for the OpenPGP registries? A little more. How many people think that it should go to, that Ron should take this to CFRG and then request, assuming that goes well, request that the Kernel group take this on? Yep. Okay, so Ron.
So just to be clear, I hummed for both 2 and 3 because they're not mutually exclusive. Like we should fix the registry and run this through CFRG before the.
Well, we will continue the discussion of number 2, but I think number 3 was clear enough to say, Ron, that what we would like to do is, because there aren't any other SM series algorithms in use now in the IETF. We're sending those to the CFRG. If the CFRG is comfortable, which I would, then you would take this to the Kernel group to see whether or not this is something you want to move forward on.
Right. I'd just like to make a clarification that it's not only the requesting of requesting the call point, is that the algorithms inside there are some specific things that need to be done to use SM2, 3, and 4 in that is documented in the document. So it's more than just a call point request, but a call point request is necessary.
Right, but it's the code point request that forces it to be IETF review. And yes.
Understand.
Okay.
Thank you.
So just a point of process, we can, Richard, you said you think we should change the registry. You say you think we should change the registry. The way you do that is by bringing that to next dispatch.
Yes. Okay. Okay.
Okay, next.
Thank you.
Is that better? Yeah. So TLS server identity binding, next. So the problem we're trying to solve is that when you have a miss issue or a fixed certificates, well, the client established a TLS session with an attacker, except of the TLS legitimate server. So both the client and the server are victim of this attack, and most of the time they don't even notice they have been a victim of that. Next slide. So what we proposed is an extension for TLS 1.3, which is a second factor authentication. So basically what it's a trust on first use mechanisms. And basically what we do is that when you're connected to a server, so let's say .example.com, you want to be sure, you want to check that the identity of that server is the same as when you were doing a session with that server previously. So it didn't change the identity. So next slide. So how does it work? So that's the first session. You have nothing. So you have performed your TLS handshake. So that's why the TLS authentication has been done. And what you're asking for from the server is a ticket. And the ticket is basically an encrypted secret based on the TLS handshake. So at the end of the session, you have the ticket, the lifetime associated to the ticket, and you generate a binding secret. Basically, the ticket is the binding secret that is encrypted by the TLS server. Is it a question? No.
Sure, Paul out. So I have a question. Isn't this TLS resumption?
No. Because no, it's not TLS resumption. You just check that you just check the ability of the server to be able to decrypt the ticket, but you're not providing any information about the session.
This is DKG. This reminds me a lot of TAC.
Sorry?
This reminds me of TAC. Do you know TACK? Sorry, I don't know what you want me to look at there. Yeah, draft parent TAC. Okay.
So
sorry,
that's the first exchange. So you just get the secret now.
Okay.
So we can go to the second step. So that how you get a ticket. And basically you're able to generate what we call the binding secret from the TLS exchange, and you have a ticket from the server. So the next session, next slide, when you perform the TLS exchange, and what you want to make sure is that the server you are actually connected to is the same as you've been connected previously. So you send him the binding ticket you received. And the server from that binding secret decrypt that secret, and generate a pinning proof, which is composed of the pinning secret and the TLS exchange secret. So once you have that proof, the other side, the client, can also generate that proof, and it can check that the proof sent by the server corresponds to the proof it has locally generated. And because you have a binding between the secret and the TLS session, you can make sure that the server is able to decrypt the secrets and has the same handshake sections as you have. So basically, that's the same server you're connected to now as previously. So when you receive that, you store that, and next time you initiate a session, you do exactly the same. Is there any question regarding the mechanisms?
Sure, Palo Alto's. So again, I think it would be useful to see why this is fundamentally different from, let's see, HPKP, TAC, HSTS, certificate transparency, and session resumption.
Okay.
So to be fair, he has some of that material both in the draft and on the slides, and I wouldn't let him use all of the slides. They didn't have enough time. So, but maybe you want to summarize quickly why you thought this was still necessary.
So HPKP, the main difference is that it's a second factor. So we do not, HPKP can be seen as you use HTTP as a side channel to configure the TLS authentication mechanisms. But just by saying this is this certificate that has to be used for the TLS authentications. We do not use that. We use a second factor, which means it's not associated, it does not have any impact to the TLS authentications. The second difference is that it's a TLS extension, so it's not only for HTTP over TLS. And well, because it's a second factor, we have absolutely no impact when you change your key for the TLS authentication. So because a lot of the difficulties for HPKP comes from that you are actually bind to the key used for the TLS authentications. So we remove that change, and that's well, we believe that, well, you don't have backup key also to handle. So we think that it's a very simplified form. It's simplified very much compared to HPKP. That's one thing.
So at this point, we need to go to the mic, and I want to remind people that what the decision that we're making here isn't strictly on the bits and the bytes. Up level it. Is this work something that we need to be pursuing in the IETF? And if so, then we have to figure out where the right home for it is. So, okay.
Benkeda, could you just confirm that this is basically the same work that was presented at IETF 97 in the TLS working group?
97, yeah, in Cell. It was not me, but it was Yaron that presented it, yes.
And so there hasn't been a huge overhaul since then?
The differences, you mean?
Yeah.
I think we refined the document, but the principles were there.
Okay.
It's probably not beyond clarifications and maybe positions, but yeah, no.
So this is DKG. You asked for questions on the mechanism, and I actually have questions on policy, so I hope that's okay.
Yeah.
But I'm curious as to what you think the client should do if the server does not produce the new pinning proof. So what do you expect to happen on the client side if the new pinning proof is, for whatever reason, doesn't match or isn't available? Is it a hard fail?
Yeah, it's a hard fail.
It's a hard fail. And so what you said, the difference between this and PKP was that you were bound, with PKP, you were bound to your certificate's key. And here, instead, you're not. But instead, you're bound to this other key, this red key that's up here, right? So I think one of the things that made it difficult for people to adopt PKP is that there was no document that provided guidance on, and no implementations that provided simple implementations of key rotation schedules and how you couple that with PKP headers, right? So the way that we could have gotten PKP to work better would be to say, here is a standard policy that you can adopt for your server, and here are a couple of implementations that implement that policy.
Yeah. So.
And do you have such a document?
Yeah,
for
that's we have. We have a ramp down, ramp up mechanisms, and well, a simplification is that you don't have to. Well, you don't need to synchronize. So that's that with the. You don't have to synchronize with the TLS the certificates key.
Okay, so you have your own separate key. You don't have to worry about dealing with the CA.
Yeah.
But you've got clients that are out there that have only seen one key.
Sorry?
I'm trying to understand. I'm a server. I have a set of secrets that are important secrets. You've added a new secret to my store, right? Now I have to protect that secret. If I lose it, I cause hard fail on all of the clients who visited me in the past, right?
Yeah.
And I need to have some policy for if I accidentally. So I have two ways I can lose it. One is I can lose track of the bit so I don't know it anymore. And the other is I can accidentally publish it, right?
Yeah.
So what is my recovery mechanism as a server for dealing with those two use cases?
So could we up-level this and say, are you saying that this is too brittle to be something that the IETF should pursue?
I'm saying that as a mechanism, I don't mind it, but I think the policy that will result will be brittle unless we have documents that describe how to manage these secrets in a responsible way.
I think we have that in the document.
So we're cutting the line at Richard.
Hi, hi, Sean Turner. So we're here, right, because you've presented this at least once to TLS. The TLS working group basically wasn't interested. They didn't say anything. There was one person that really got up and said something, and it was pretty negative. And you need a code point, and that code point is still the whole standard track thing. We're changing that. So in TLS, we said we're going to open up the Cypher suite or the registry for extensions to be spec required. So once we've done that in the next 2 weeks, month, or whatever, it'll be available for you to take this experimental draft to the ISC and get a code point. That's fine. And that's what I think we should do, because I think there was not a lot of interest in the working group, and I don't want this working group to become TLS Part 2. That's not what I'm planning.
This working group would not follow any document through. With dispatch, if it became a group, would not follow any document through. It makes things someone else's problem, or it makes them go away. That's the goal.
We are going to reiterate, we are dispatch, right? This group does not take any work.
Okay.
But
Richard.
Last one.
Yeah, Richard Barnes, and I guess since I'm the last in line, I'll take the privilege of proposing a resolution here. I think following where the direction Sean was going, I think we should not do any work on this. I think it's something that can clearly be done outside the IETF process with the new registration policies. And I think it actually is pointed in a direction that is not really a direction, at least the web is headed. HPKP support is being rolled back in a bunch of browsers now. And so because people had exactly the problems that DKG was mentioning in deployability. So I don't think this is really something that is in tune with what I understand to be the direction that the internet is headed. And there's alternative channels for realizing. So I don't think the IETF needs to do any work for it.
So I think that's straightforward. That from what you and Sean have said, it's going to become specification review, which will allow you to get the code point that you need. And there probably is not interest in the right working group to pursue it. So we would suggest that be how you proceed. As independent submission. Is there anybody who thinks that that's a bad summary? Hum now. The summary is that since TLS is going to change to specification review, and there really isn't sufficient interest within the community to follow this document through, if they want to get the code point, they can do it by independent submission, and that would be what we would suggest. The TLS group is doing what they're doing, and then they can. Is that?
So I Stephen Farrell, that's what you said is a totally true statement until you said, and that's what we would suggest, because we might want to suggest this is a bad idea.
Yeah, but I think that's the whole point of independent submission.
I mean, it's a bad enough idea that the independent stream that the IETF shouldn't do anything about it, but like we can't stop him from putting it on a website and requesting IANA register a code point.
Stephen Pearl again. Yeah, no, the reason I'm doing it, because my understanding of this process is to provide an effective way to say no. Not
Well,
just,
yes, but-
we suggest you can go and do something else.
But we can't say no to an independent
So-
stream submission.
so
But we're saying no to this community supporting the work further.
Right. Yeah. So I mean, so the point of the co-point reassignments in TLS, right, were to avoid having to make up-down decisions on documents when people are running co-point assignments. Sure. And I don't think we're taking any position on the independent submission. It's like, don't do it here. This is how you get a co-point assignment.
So all I'm suggesting is that for the purposes of this, we should just stop at don't do it here.
That's fair enough. What we're saying is we're not going to pursue it in any of the working groups here. Hum now if you agree that we should not pursue this in any of the working groups within the security area. How many people think we should pursue this within the security area? That seemed clear enough to me. Okay. Okay. Nick Sullivan.
Okay, this one had no title. I can't remember who.
This is Nick Sullivan for randomness improvements for security protocols.
This is not mine. Yeah, this is it.
Okay, hello.
Oh,
I'm Nick.
sorry.
Can you hear me? Okay, great. I'm Nick Sullivan. This is a proposal that's a very simple proposal that should help out with several security protocols. Next slide, please. Okay, so the general problem we're trying to solve here is system-level randomness failures. If you think back to the Debian bug and other sort of things where the system itself can't seed the pseudo-random number generator with an unpredictable data, this can happen on different operating systems and can end up impacting quite a lot of implementations of protocols, especially in the case of ephemeral Diffie-Hellman, where keys are generated on the fly for connections. If there is a system level randomness failure, you could expect that lots of connections are compromised at the same time. Next slide, please. There have been general solutions proposed to this sort of issue before. The idea is to take a long-term secret that's specific to the application or the connection and mix that in with the randomness. This was specifically presented as the Naxos trick in a paper by Lamacchia, Lauder, and Mitiagan. The idea is you have the private key. This is a long-term secret. In TLS, for example, this could be the private key of your certificate. You can hash this into the RNG pool. So if there's a systemic failure on your operating system, at least your connection will have the entropy of the secret key mix into it. The issue with this is that sometimes the private key is not available, whether it's in an HSM or other places. So the proposed solution here is very simple, is given a long-term asymmetric key, you sign or encrypt a static value with this long-term key, and then mix that result into the random number generator before using it for generating ephemeral Diffie-Hellman private keys. We have an example of how to do this in the TLS draft and a formal security proof that came along with this from my co-authors. Next slide. That's basically it. So is this valuable? Where should it live?
Stephen Pearl, yeah, I think this is a good idea for somewhere. I mean, I would ideally like to see somebody update 4086, but I can't force you to do more work than you're willing to do. So if you're not happy to update 4086, if you were, I'd be delighted. If you're not, then I think doing this somewhere would be fine. And it could be 80s one.
Nick, thank you. Stanislas Mishlev, I would like to ask you for a small clarification. Are you talking about using private keys with some deterministic algorithms or with probabilistic ones? So do you want to sign some static value with deterministic algorithm, or is this about more complex scheme?
This should work with either deterministic or randomly generated signatures. The important part is that the resulting value is signed by something that is an unpredictable long-term secret. And for example, if you were to, in TLS, if you have an RSA key, you can sign a value deterministically. With ECDSA, you can sign non-deterministically. The signature itself is not predictable, which is the important part. And you can take this signature and sort of share it along. You don't have to actually do this for every single connection. You can kind of do it once per long-term secret, as long as that piece of those bits are fed into the RNG everywhere. You should have protection from the systematic failure.
And the same question for the static value, which is signed. Is it static, or it is some time dependent or counter or something?
This just has to be static. You can have, say, a single string for TLS, the protocol, for example.
Then it's only for a single usage, yes? So if you have deterministic signature, a static value, so it's only for one usage, no?
Yes, and the point is that you mix it in with the system randomness, and it adds at least as much entropy as the secrecy of that private key provides.
Okay, yes, and ad hoc solution, it might help in some critical failures. Thank you.
Thanks.
Hey, Nick, this is a technical question, which I think I know the answer to, but I want to double check. As you know, ECDSA in non-deterministic mode requires a random K, and having a non-random K is bad. So if you have so now we have a chicken and egg problem. If we have a weak PRNG that we use to generate the K, does that cause a problem, or is the fact that the fact that we're assuming the PRNG is inherently strong, just badly seeded, remove that problem?
So the only issue with predictable Ks is if you do multiple signatures. So in the case of ECDSA, you would want to do one signature per long-term key, and that would be safe.
Thank you.
I was curious, have you done any testing on the, say, Linux system RNG and see what kind of results you get from the resulting entropy after you've sort of cold started?
Sorry, can you repeat what?
So did you try this out with, say, the Linux system RNG and say cold started it and just fed it this and see how much entropy did you actually wind up with?
It's very difficult to measure entropy.
But there are statistical tests you can do.
Statistically, if the system RNG is random, this will be random as well. Any public key signature or encryption algorithm of a static value will imbue upon the result as much entropy as is the key length or the key strength. And if not, then that signature algorithm or encryption algorithm is weak.
Right. I was just curious whether you actually measured it on real life systems.
We haven't measured it. I'm not sure what exactly we would even measure.
All right. I mean, you could. All right, we can take it offline.
Sure. Statistically, it's going to look random.
Rich Sauls. Yeah, hi. This is a cute, short, neat hack. We've tried to rev large fundamental parts of security policy and recommendations before, so let's just give this over to CFRG and have them publish it.
So, I mean, there is no code point or anything that is needed, so there's no reason it couldn't go through the CFRG. And I think we're having enough questions that it might be something that just going through CFRG would actually make people feel more comfortable about using it as well. So that would be certainly an option. Did you actually consider that, or is that?
Yeah, we considered CFRG. We just thought that there was a chance that maybe this could be an AD sponsored document. Sec-Dispatch seemed like the right venue to make that decision.
Yeah. It's exactly what we're here for. So that's fine. I just wanted to know whether you had ruled it out for some particular reason. Okay.
Yeah, personally, I think does seem to be like a little higher level up the stack than CFRG typically deals with. So I think it seems like a useful bit of both in the sense of being sort of a construction built out of cryptographic primitives as opposed to a primitive itself, and in the sense of being closer to a mechanism you would leverage in a protocol as opposed to a generic primitive you would use as something to be agile around. So this seems like it would make sense to me as either a tiny short-lived working group or an AD sponsored document if the ADs are willing to accept it.
So what was the first option? You said it makes sense, but I missed the first one.
Oh, so one of the things, so changing hats over to former RAI area director, one of the things we've done in the RAI area with dispatch is if there's a document that needs a little bit of work, needs some review, things like that, you can spin up a working group to focus just on that document. So we've had some documents come through RAI dispatch that had a small working group that lasted, 3 or 6 months just to deliver one document. So fairly focused, fairly quick hit, and then shut down the working group. So, I mean, if this doesn't really seem like it merits quite that much effort. So I think AD sponsorship is probably better, but that would be another option if the ADs weren't comfortable taking it directly that way.
Okay.
About one argument to say about CFRG is that these kind of solutions are used in some system I'm aware of, but they're used with timestamps as a part of an input of signed data for meshing into the PRNG. And I think that kind of techniques can be used when no other good choices left, but they must be analyzed, so maybe this is good work for CFRG. Thank you.
Thanks.
Oh, yes. Okay. And actually, if there's other techniques, that would be another reason to spin up some larger effort that somebody might want to do. So, okay. So I think we have 3 options. We'll do a quick hum. I think the 3 options, as I understood them, would be pursue this, take this to the CFRG, actually spin up a working group to actually look at other possible ways to do the same kind of thing, other techniques to include this and refine this, but maybe add some other pieces. And the third one would be AD sponsorship. So
let me just try to narrow that a little bit. I think what I'd like to hear from this group is, do you think this is suitable for AD sponsorship? And then Kathleen and I can have a conversation whether we'd like to do so. I don't want to get in point of the working group humming on whether we sponsor stuff.
Yeah. So let us do the first 2 hums and see where we are
Thank
there,
you.
and then the third one we can say. Right. Go ahead.
All right. So how many people think that this work ought to be taken to the CFRG? Please hum now for yes. How many people think that this merits spinning together a BOF or maybe going directly to a working group to work on something fairly focused but in this area? Hum now. Okay, I think that we'd like you to take this to the CFRG. It seemed like there was a lot of interest, but a lot of people thought it ought to go to the CFRG. I don't think we need to do do we need to do the third one? How many people think this should just be AD sponsored? Then we should ask the ADs to consider AD sponsoring this. Much weaker. Okay, so CFRG was it. Okay, thank you. Okay. So next is Max Paul.
Hello. Hi. Okay. Max Paga, Cable Labs and OpenCA. I'm here to talk about a simple idea, OSSP over DNS. It's been around for a while. Next slide. So the idea is very simple. Enable DNS as a threshold mechanism for OSSP responses. And this is all it is as a proposal. Next slide. This comes with some benefits. Most importantly, an increased availability for revocation information to validate certificates, mostly because of the nature of DNS. The data is closer to the user. And the caching system of the DNS might actually help in reducing the cost of running the revocation or providing revocation information for large infrastructure. Also, there's other added benefits. For example, if where DNSSEC is deployed, you can actually address the problem that we have today with distributing DOSP responses over HTTP. Most of the time is HTTP, not HTTPS, distributed through CDNs. This comes with costs, but also comes with the possibility for man-in-the-middle attacks to prevent you from reaching the revocation information. And on top of that, it doesn't suffer from the circular reference of, okay, I want to use TLS, so I have to validate the TLS connection, etc., because it uses a different set of keys. Other benefits that come from this is that, in some environments, think about some devices that comes online in a network, and before they're actually allowed to perform any real action or even access HTTP, HTTPS resources, they need to provide some form of authentication or authenticate some servers that they need to connect to. DNS might provide a way to actually validate the validity of the certificate that's presented by other parties. Could be IoT devices communicating between each other, or communicating with a controller, or even the device fetching their own OSSP responses and embedding them in the TLS session with other devices, stapling that. And of course, there's it's just a DNS query, which is fairly simple for application to do that. They don't have to build OSSP requests. Next slide. So the draft is very simple. Technically, there's two things that we define. The one is a record for the OSSP response data in the DNS. It's just the binary representation of the OSSP response. The draft doesn't propose to do any changes there. And the use of DNS URIs in the certificates, so that applications can actually use that and fetch the OSSP response related to the entry that is in the certificate itself. Next slide. So what's the impact to the application? Very little, in the sense that usually you do these three things. First, retrieve the URI from the certificate, from the authority info access with the access method ID or CSP. That doesn't change. In the proposal, basically, if the scheme in the URI is DNS instead of HTTP, as usually it is, then you do the query through the DNS system. And then you just process the data that you receive, because it's the OSSP response. Very simple to do, and doesn't really impact that much the processing of the from an application standpoint point of view. Next slide. So this is all it is. It's a very simple proposal. As I said, definition of the record for the DNS. We provide some example on how how HCA can actually build this target for the DNS by using maybe the serial number of the certificates. But since we don't mandate a specific format, because we want the client application to be very easy for the client application to just get the target from the certificate and just make the query, we don't mandate for any particular way to construct this URI. And as I said before, there's some advantages that come from the nature of the DNS itself, the distributed cache, the globally distributed cache, that might help in reducing the cost of providing revocation information. And in some environments like OCF or CMI, where we're introducing actually strong authentication for devices, this might be a way to improve the security, the overall security of the system, where short-lived certificates is not really an option. And that's it. That's all it is. So, questions?
Martin Thompson, not a question, a comment. So the only thing that I found remotely interesting in this was the discussion of caching. It turns out that there's a much better mechanism that already has far better caching than what you describe, and that's OCSP stapling. Why not use that?
No, you can use that, absolutely. But someone has to fetch that stapling, right? That OSSP response. So for servers, right? For servers is easy. For client might not be as easy. it's just, I'm not saying that is a replacement for, you know, the way that you do today. If you can do OCSP stapling for TLS sessions, perfectly fine. There's many other use of certificates that might not have that option. And so it's just in addition, not a replacement for what exists today. If today your application just works fine, you support OCSP stapling, that's great, do it. In other environment, might not be as easy.
That doesn't really, I don't find that at all persuasive. The other point that I would make here is that you said that this would reduce the cost of providing revocation services. I don't think that's true, because most of the cost is in signing, as someone points out behind me. And what you've done is you've created an externality. Now the DNS is responsible for holding all of this information, and it doesn't need to hold it in every single recursive resolver that's ever been touched by this DNS query. There's really only one place that you need to put this, and that is the entity that's going to be presenting the certificate, which is, again, why stapling is perfectly adequate. Thanks.
So we're cutting the mic lines there, and I'm asking everybody to be very efficient so that we can get one more presentation in.
Sure.
So, sorry, I just wanted to reply to that.
I was here first. Sorry. I was back here before you were. I've been waiting. Tim Wasinski, DNS Op co-chair. 2 comments. No, I was here before him.
No, but Max is trying to respond to the previous.
So he's going to that with it. Never mind. Go ahead. Go ahead.
Martin.
Go ahead.
And then you, yes.
For the cost of providing the revocation infrastructure, you're right, there's a cost associated with signing those responses, but most of the time now, many large CAs, they just pre-compute those and put on CDNs. Access to CDNs, CDNs you have to pay for that. So that's the cost that might be reduced in case of you have large number of clients connecting directly via HTTP. This is happened in the past, and you get for high volume and high frequency systems, you get billions of requests a day, and that's associated with cost. So this should.
Okay.
Yes.
Yeah, I'll be real fast. 2 things. One, you can request a DNS RO type because it's all pretty straightforward without any sort of expert review or anything like that. Just go to IANA and fill out the form, and you can get that RO type right away. Second, I think DNS Op will sort of give you the advice that, of course, you should use text records, right? So there you go. Thanks.
Okay.
That's exactly what I was going to say, that new RO types do not deploy on the internet. And DNSSEC has kind of the same property here that's not going to make anything better, because there is no circular dependency on any transport security, because the OCSP requests themselves are signed. And so that addresses the security concerns you have.
Yes,
so
but
DNSSEC is only going to be a deployment blocker. It's only going to introduce more breakage. So my answer is, I think we should do nothing here.
Okay.
Okay.
Bjorn Metzdorf, Apple. I have a couple of questions. I think my first question, actually, let me address the OCSP stapling comment from, I think, Martin. OCSP stapling is, well, one disadvantage of OCSP stapling is that it's always sent by the server on any new handshake, basically, and that might not be needed because the next update for an OCSP, the request is typically in the time frame of weeks. So it's just additional bytes that are not really needed. So this out-of-band fetching, or actually it's in the request path, but this fetching from either DNS or CDN as it's done right now, it's probably still a valid thing to do. My question is, though, that I just looked up the RFC for OCSP, and it seems to be that the request payload needs to carry a little bit more than just the serial number. In fact, you mentioned in your draft that the serial number is even kind of optional in the DNS URI that is in here. But in fact, there's more information in the request payload that probably cannot be conveyed through DNS request here.
So we're going to have to skip past those details. You guys can take that outside, because the decision here is a meta one. So my apologies, but we just need to keep it moving. We have 2 more. Yep.
Hi, Sean Leonard. So overall, I'm in favor of this work. It's not the first time that OCSP over DNS has been presented, and I think that the time has come to give it a try. I did read the draft. It is experimental, and whether it becomes experimental or not when it's published, I think that a working group approach, because there are there are dragons here. There's implementation details, but I clearly see their applications. And as somebody who has managed to cram a lot of superfluous information into DNS and significantly reduce our operating costs, I think it's a good idea. So.
Matthew Miller. So, I kind of reflect what Martin said, but also, so this is to, get around possibly over caching on the CDN. What about the caching proliferation that happens with various DNS caching resolvers? I don't think this is going to make the problem any better. It could actually make it a lot worse.
Okay. So I think we'll start with the simplest question. Is this work that ought to be pursued in one form or another within the security area? Hum now if you think it is work that should be pursued within the security area in some form. How many people think that it doesn't need to be pursued within the security area? Hum now. That one is stronger. So you have the other option that was suggested about from the mic at the back. Okay? Thank you. So we got one last one, and we are right back on schedule.
Yeah.
You do have your full 10 minutes. So, okay.
Yeah, and I'll apologize to Marcus because we ran out of time.
Yeah.
All right. Hi, guys. I have 3 things to say. This will be short, I think. All of them are around EAP that the IETF started working on in the early 2000s more extensively. We defined the framework and multiple different EAP authentication methods, including EAP SIM and EAP AKA. This presentation is around EAP AKA. That has been actually fairly widely or very widely implemented. If you have a phone in your pocket, probably implements EAP AKA. It's been somewhat widely used or deployed, and actually using the implementation, like millions, not billions of users. Primarily because it's not the method that one uses for if you have a 2G, 3G, 4G network. You're using a native AKA authentication scheme and a 3GPP protocol to do the authentication, and EAP is only used if you were to access a wireless LAN with your operator credentials. But in 5G, this may actually change because the 5G signaling mechanisms will allow use of EAP to authenticate phones that connect to the 5G radio. So that's the information piece. Next slide, please. So I have 2 drafts around this topic. And one is a very simple update of the existing latest RFC 5448 on EAP AKA Prime, which is a further development of the original AKA draft. And this minor update relates to actually just one reference in the old RFC points to a version of the 3GPP spec that gives a table of how you bind certain contexts where you do this authentication into the keys of the authentication method. And that is planned to be changed because now there will be other context, namely the 5G context. So if you authenticate with, within the 5G network, you'll use a different string to mix with your key. And that's really like the smallest possible reason for updating an RFC, but I actually happen to believe that if you have even the smallest issue in an RFC, you should fix it, and I think the IETF should be able to do that sort of thing. So that's the update piece. There's no idea of updating anything like adding functionality or anything like that. Of course, you could consider adding security considerations if you learn some new things, and you actually have learned some new things. I didn't do any of that for this version. Take a look at the draft and please provide your comments. Next slide, please. So the other draft actually relates to attacks and relates to pervasive surveillance concerns. So after the Snowden revelations, some of the follow-on revelations were actually quite interesting from the point of view of the mobile networks and SIM cards. So we had this story in the newspapers around some intelligence agencies breaking into the systems or the organizations of the SIM card manufacturers that manufacture these by the millions or hundreds of millions and deliver them to the operators. Basically saying that in some cases the agencies have been able to get to the smart card manufacturers, the actual data in the card through the manufacturing or provisioning process, and that's nothing to do with the actual technical means of actually even the cards or the authentication protocols. This is like a other level of attack if you have national security letter, or you blackmail the guy who does the manufacturing process, or have a point a gun to a person. You will get some key material no matter what the technology is underneath. But it does point to sort of changes in the security situation or threat situation. So we should assume that some of this could be happening. Next slide, please. So obviously the operators and the operator associations have been looking at this very seriously, and they've done many improvements. So they taken very seriously now the whole process, like who gets access to the manufacturing process and their technical tools, and how they communicate the keys between the manufacturer and the operator authentication center. But nevertheless, I don't think we can rule out that some vulnerabilities remain. So this other draft, I won't go into the technical details, but the basic idea is provide perfect forward secrecy, which we didn't have in the original EAP-AK version. And with perfect forward secrecy, of course, you can get protection against passive attackers. If the agencies get the keys, then they don't necessarily get the data of the user's traffic. So details, you can look at the draft. There's no current official requirements for this from 3GPP or anybody else, but I thought this would be a prudent technical move on our part. Next slide. So next steps, happy to get feedback. If we could get some of this into the work program of the IETF, I'd be really happy. Should point out that there's some coordination going on with IETF and 3GP on various topics. On the EAP space, there's actually more than this particular topic that I'm talking about now. And I'm keen on updating the existing RFCs that they are up to the current situation, and I'm also keen on worrying about threat situation with regards to intelligence agencies and pervasive surveillance. So that's it. Maybe one more thing that if you're thinking about EAP in general, there's also some other drafts in this space that we're not talking about here now, but that may factor into, like, if we put some work somewhere, do we want to do it where? So that's it. Thank you.
So Jari, are you actually looking for new work in the security area with this, or are you looking for groups to get people to pay attention to this work? I'm trying to think. Dispatch now are you asking us to dispatch any of this work at this point?
I would like a place for this work to happen at the IETF, and also obviously very much interested in technical feedback.
Okay.
So Kathleen Moriarty, we have had recent drafts pop up on the SAG list in regard to EAP, and there's been confusion about the list, and they had created a new list. We had allowed that to happen. The old list is still actively used, but when I just tried to get to it for the EAP list, you just wind up with a login page. So maybe those subscribed are still happily getting their EAP messages, but might be difficult for people to join. So I think we have to straighten that out and also find out the larger interest in this space, and maybe just use this new REAP list. So I think there's more to this decision, but I am seeing what Jari is saying is there seems to be a lot of renewed interest. Okay. And so I'd like to hear thoughts as well to help us with decisions.
Okay, but we're cutting the line.
Cut. We're with the gentleman in blue. Sorry. We are really running out of time.
Because we are.
Yeah, my name is Hai Guang from Huawei. Thank you very much for the presentation. Actually, I myself is one of the contributor to the 5G security standard in 3GPP, and I'm quite agree with the proposal here, because recently there are some new attacks for the appeared for the telecom networks, and and the 5G adopted the EAP framework for the authentication, and so I think it is necessary to enhance the EAP method for the future use.
Great,
Yeah.
thank you.
Thank you.
Okay.
Thank you very much. My name is Georg Meyer. I'm the 3GPP liaison to IETF. I just wanted to say thank you for Yari for bringing up especially the first, but also the second draft. EAP is for sure success story, and I would really like to see that that the drafts are going forward and can progress. And thank
Great.
you.
Thank you.
Thanks.
The last one, then we'll do a quick comment if people
Thank
can
you.
hang on just a moment.
I'm Mingpeng Qi from China Mobile, and I think that the EAP work is very important for the 3GPP, as that is the first time that you use the EAP for the wireless for the wide wireless connections. So I think that if we have more EAP methods, then the 3GPP method can have much more choices for their the authentications. Thanks.
Thank you.
Thank you.
So I think let's do a quick either. So the choices are, do you think that these two drafts and perhaps others in the area of EAP are important enough that the security community should spin up some new work and take this on? Hum now if you think we should do that. How many people think that that we should not? Okay, I think it's pretty clear that something should happen. So we're going to have to figure out. I don't think we don't quite have the what, but we'll work on that. Thank you, Yari. Thank you, everybody, for your patience as we work this experiment.
Oh, don't forget blue sheets, and please, I need the get well cards back so that Russ can get them. I'm so sorry.
Yeah, Henry didn't. Thank you. Yeah.
Were you in power? I was there for almost a day, so no, it's entirely possible. See you in many